Hey there, welcome to Pomodoro Joe for Tuesday, October 31st, 2023. Happy Halloween, everybody. All right, let's see what we're doing today. Today we're looking at LeetCode problem 2433. Find the original array of prefix XOR. This is a medium problem. All right, we're given an integer array, pref, of size n. Find and return the array of size n that satisfies, let's see, pref index I is equal to, all right, so this is sort of backwards. The thing that we're given at index I is equal to the original array at 0 XORed with the array at 1, XORed the array ... up to the array at index I. Okay, so what we're given is this pref array, and its values, every value in this array, is the original array's values XORed up to that index. Okay, so note that the little caret denotes the bitwise XOR operation. It can be proven that the answer is unique. All right, so let's look at our first example here. So we have 5, 2, 0, 3, 1. Now this is the post XORed values. So this is basically the original input XORed up to index 0. So that's going to be 5, all right? Now the second value will be the original array's index 0 XORed with the original array's index 1. So that's 5 and 7 here. So 5 XOR 7. So let's just do a little bitwise math here. So 5 is a 4 and a 1. And a 7 will be 4, 2, whoops, let me do this, 4, 2, and 1. So that's 7. Now if we do a bitwise XOR of this, well, 1 XORed with 1 is a 0, 0 XORed 1 is a 1, and a 1 XORed 1 is also a 0, so that gives us a 2. So 0, 1 bits, 1, 2 bit. And that gives us 2 here. Cool. Okay, so we can go through all of this, but I think you get it. Now the question is, how do we sort of reverse these XOR operations to go from the XORed values back to the original values? So let's see. I guess we'll put 25 minutes on the Pomodoro timer now, but we're not going to start coding right away. We are going to do a little bit of an investigation of the XOR operation. So let's do a truth table for the XOR. Actually, let's start even further back. Let's do a truth table for OR. Or let's do a truth table for AND. This will be easier. So truth table for AND. This is a bitwise operation. AND. All right. So we have A, B, and that's going to equal some C. So this is A and B equals C. All right. So let's do this. 0, 0, and then I'll put a question mark here for now. All right, so here we have our standard truth tables. We have an A and a B. These are just bits, and it can be a 0, 0, a 0, 1, a 1, 0, or a 1, 1. All right, so if A is 0 and B is 0, then if we AND them together, what do we get? Well, we get a 0, because 0 and 0 is another 0. So the AND operation will be true only if A and B are 1. So 0 and 0 is a 0. 0 and 1 is a 0, because one of them is 0. 0 or 1 and 0 is also 0 because one of them is 0. And 1 and 1 is the only one that results in a 1 for the AND operation. Okay, so that's pretty straightforward. We're saying A and B are both 1s. So the only case that that occurs is this case down here. All right, let's look at OR. So now with a standard OR, just regular OR, now this is going to be A or B is a 1. Well, in this case, A and B both being 0, we get a 0. But A0, B1, well, one of them's 1, so we get a 1. And 1, 0 is a 1, and a 1, 1 is a 1. So this is our standard OR operation. 0, 0, 0, 0, 1 is a 1, 1, 0 is a 1, and a 1, 1 is a 1. Now the exclusive OR operation, or XOR operation, now this means only one of them is a 1. So we're saying exclusively an OR. Only one of them can be a 1. If they're both 1s, it doesn't count. So in this case, 0, 0, still 0. 0, 1 is a 1, 1, 0 is a 1, because only one of them is a 1, but 1, 1 is back to 0. So this is our XOR operation, exclusively OR. All right, so how does this help us? One common use of an XOR is to encode a message. So if we have some message, all right, I'm gonna do this. If we have some message, I'll call it M, and then we have some secret key, I'll call it K. If we XOR these together, let's do this. So our encoded message will be M XORed with our K. So this is a bitwise operation. Now we can apply the XOR to not just single bits, but entire strings or lengths of bits. So our secret message could be, or our input message could be like this, and then we have some secret key, which could be something else. Not a 2, but so as long as they're the same length, we XOR them together and we get some secret message out here or encoded message out here. Now, I'm not going to actually do the XOR on this, but you can just follow this truth table and find the value for this encoded message. So now we have this encoded message. How do we get the original message back? Like if I give somebody this encoded message, it's just going to be a bunch of bits. How do they get the original message back out? Well, it's pretty simple. They just take the encoded message and they XOR it with the secret key. So let's see. I'll call this E for encoded. So to get our message back out from our encoded message, all we have to do is take our secret key and we XOR it with our encoded message. Okay, so this is something that is used in sort of encoding or in cryptography. You can take a message, you can XOR it with some secret, then to get the original message back, you just XOR it with the same secret and you get your original message back out. Let's do a quick dive and see how this works. So we've got our A XOR B truth table here. So 0, 0, 0, 0, 1, 1, 1, 0, 1, and 1, 1 is a 0. Now what happens if we take our encoded message, or not encoded message, we take our XORed value. Let's do this. All right, now if we take our C and we XOR it with A, so that's going to be 0 XORed with 0, well, we're going to get 0 back out. We take C XOR it with B, 0 and 0. We get another 0 back out. Now, one thing that's not clear based on this example is that C XOR A will give us B. It does work, but since they're both 0, it's kind of unclear here. C XOR B gives us A, kind of unclear here. But now in this case, we have 0, 1 gives us a 1. So C XOR A, that's going to be this 1 XORed with A, which is 0. Well, that's also going to give us a 1. All right. And now C, which is a 1, XORed with B, which is also a 1, well, that's going to give us 0. So now if we look at this one, it's a little bit clearer. So we have A is 0, B is 1. It gives us C, which is a 1. Now if we want to get B back out, we can take C and XOR at A, we get B. See, B was a 1, and we get a 1. If we want to get A back out, we can say C XOR B, and it gives us A. So that's 0, 0. And the same thing holds true here. So C XOR A, well, they're both 1, so we get a 0, which is B. And let's see, C is 1, B is 0, so we're going to get a 1 here, which is A. And now down to the 1s. C is a 0, A is 1, so that's a 1, and C is a 0, B is a 1, so that's a 1. And again, we're going to get our opposites back out. So C XOR A gives us B, and C XOR B gives us A. Okay, so this is sometimes called bit flipping. Basically, we can get our original value back out just by doing an XOR again. So how's this going to help us? Well, let's get to coding. All right, let's take a look at our prefs here. So our first pref, 5, well, that's just going to be the same value as our first element in our original input. Because there were 0 elements before, it's just going to be 5 XORed with, I guess, 0. It doesn't really tell us. Maybe it's just array 0 with no XOR to it. Let's see if I can diagram this out actually. Let's say this is our array. We've got 1, 2, 3. Actually, I should start at 0. So we've got our A. Our A is just going to be the value at this index. So let's grab this actually. So this is our equation over here. I'll just make some definitions down here. So our A, well, our A is going to be the thing that we're XORing with. So that's going to be all of the values up to our index. So it doesn't include that last value. B is going to be this last value that we're XORing with. All right, so A is going to be all of the values leading up to our index XORed together, and B is going to be the value at our index, and then C is going to equal the whole thing. So A XOR B. So this is A here, and this is B here. So this is going to be A. So this is A XOR, and this is B. All right, so hopefully this is clear. This is our formula for getting our pref value. Now our A is going to be all of the preceding values, not including this current index, XORed together. So that's this part of the equation. And then we're going to have B, which is just the value at this index. So we need to take all of A, XOR it with B, and that gives us C. Okay, so C is the thing that we actually put into our array pref, or that they give us in our array pref. Now, we already know, based on our previous explorations of XOR, that to get our C and transform it back into our B, because we're looking for this value at this array, so to turn C back into a B, all we have to do is take C and XOR it with A, right? So if we take our C, the thing in our prefs here, we XOR it with A, which is all of these values XORed together, it will give us our B back out. All right, hopefully that makes sense. And if you understand that, then here's the next little leap that we have to do. So this A for our B here, this A for our current B is really just the previous value in our prefs array, because that's just all of the values leading up to and including this last array. So essentially, let's see if we can explain this. So we're just moving, let's see, maybe it's better if I just point it out here. Yeah, actually this might be easier to see it here. Let's look at this prefs 4. So prefs 4, we're going to take all the preceding values. This is our A, 5 XORed 7, 2, and 3. And we're going to XOR it with our B, which is just 2, right? But if you look at this stacking here, this whole A is actually the entire previous value in our array. You can just see it just transfers directly down. So this entire A is the previous value in our prefs array. And if you look at the stack above that, so you can see this is our B, just 3. This is our A, 5 XORed 7 XORed 2. Well, that's just the previous value here in our prefs array. So all we really have to do is just look back one value in our prefs array to get our A out. All right, so let's just go through and do that, because I think hopefully it should make sense at this point. So some result, it's going to be an empty array to start with. We'll return our result at the end. All right, now we just have to go through every value in our prefs array here. So we'll keep track of the previous val. And for this, it's going to start as 0. And then for every value in our prefs array, we're just going to do the XOR and then add that XORed value or append that XORed value to our result. So our result, actually maybe I'll do it this way. I'll call this A. We'll just keep the same naming. So A starts as 0. For every B in our prefs here, to get our C back out, it's going to be A XORed with B. So our result will append A XORed with B. And then we need to update our A. So our A now becomes our previous value, which is our B. Cool. So that should do it. I don't know if A or B makes it easier to understand or if previous value makes it understand. Let's do this. Let's do this. So the previous value and our current value. So all we have to do is take our current value, or our previous value, we XOR it with our current value, and then we have to set our previous value to the current value. Right, because we're going along from left to right. Cool. Well, let's just see if this works. Okay, seems to work. Let's submit to see how we do. And we pass. And we do pretty well, actually. Holy smokes. We're beating 94% for runtime and 31% for memory, so that is great. All right. This one can be tricky. If you understand XORs, or if you don't understand XORs, I recommend play around with them. It's kind of a unique operation with some unique properties, so definitely worth understanding. All right. Well, we are low on time, so that is it for me. Hopefully this made sense. All right, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.